Start recording. Hey, okay. So what we're doing today, in physics, we're looking at forces as vectors. Okay. Now I'm going to be very clear. You guys have been doing so well since year 7 that I'm teaching you language that really makes physics a lot easier. That doesn't mean it's easy, especially if you're new. You're going to get used to these words. And the key thing I'm going to say is try. All right. The easy answers you all should give a go. The answers for the easy answers are right here, and especially what I tell you. The medium ones, I'm going to go through a few and just give it a go. All right. So let's talk about scalars and vectors. These are two different types of quantities that we've done before that you need to know. A scalar has size only. We call it magnitude. And I always love using the example of speed. The unit of speed can be anything miles per hour, kilometers per second, anything. However, in physics, it tends to be, especially when you're older, meters per second. So speed, someone says, do you know what? I'm running like 10 meters per second. Right? I'm running as fast as Usain Bolt. Fine, you're running at 10 meters per second. All right, but I don't know which direction you're going. So this is a scalar. Now, a velocity, a vector is two things. Is how fast you're going, the magnitude, the size of the thing, in this case we're looking at speed, so of velocity, is what number have you got? Well, my number's 10 meters per second. So as a vector, which would be velocity, now this is horrible because I'm using two words that start with V. So speed is a scalar, velocity is a vector. And the funny thing is, one of the ways of thinking about vectors is, can I draw it as an arrow? So if my velocity is 10 meters per second, the units are the same. However, because it's a positive number to you young ones, it's moving to the right of the page. This is how a really good way of working out whether you've got a vector or a scalar. Velocity, you can draw an arrow. If speed, we'd never give speed as minus 10. There's no point because it means it's meaningless. The speed will always be a positive number. Now, if velocity was given you as minus 10 meters per second, that for you guys is moving to the left of the page. All right? So vectors, you can draw as an arrow. Now, force is a vector. And what do I mean by that? So I'm going to give you an example. So me and my husky, we've got a young husky. Our older ones know what they're doing. Younger ones need training. So I took him out for a trip. So off for a trailer pull. So when we draw physics and we think, a car's moving, a trailer's moving, or a person moving, we draw them as a circle because it's easy to draw. So I was pushing forward with a force of 100 newtons. So as you can see, I can draw it as an arrow. All right. So anyway, normally, Newt, which is our new little semi-head, was pulling to the right at 30 newtons. I was like, yeah, that's really cool. So me and Newt had a forward force, he's called Newt. Our resultant force, so what was the result? The resultant force was really nice. It was my 100 newtons plus his 30 newtons with total forward force of 130 newtons. Well, yay, all good fun. All right. Now, unfortunately, Newton's very young and very easily distracted. Newt isn't named after Newton. He's named after Newt Scamander because my kids really like Newt Scamander, so they named our new husky after Newt Scamander, not Newton, which is a really good one for physics. So anyway, there I was, pulling forward with a force of 100 newtons. Little monkey boy saw a rabbit and decided to go in this direction with a force of 30 newtons. But this is to my left. So that to me is minus 30 newtons. So what was my resultant force? Well, it was 100 newtons minus 30 newtons, which gave me a resultant force of 70 newtons. Yeah. All right. Now, what happens? Let me get rid of my notes over here. And get rid of them. So what happens when he gets bigger and things go wrong? So now I'm pulling forward with a force of 100 newtons. Now imagine Newt is now 2 years old and big and strong boy, and he decides to go, oh look, rabbit, other direction. Minus 100 newtons. Our resultant force Our resultant force is 100 newtons minus 100 newtons equals 0 newtons. Right? That's it, we're done for. We are no longer, so two things happen, two possible things. Either we are not moving. If we're stationary, if we start off stationary, we're not moving. Or if we were really moving, there is no change in speed. So our speed is constant. All right. So if we're already moving, right, we're still moving, but our speed doesn't change. Okay. And that's a tough one because people think if there's a resultant force is 0, then you stop moving. Yeah, sometimes you do. If initially you weren't moving and the resultant force is 0 newtons, you're still not moving. But if me and Newt were moving at, let's say, 10 meters per second, and he decides to go the other way, the resultant force is 0 newtons, but we're still moving forward at 10 meters per second. Our speed doesn't change. And you'll notice something else. The size of my arrows matter. So my arrow shows two things. Right? My arrow shows, arrow's head shows direction. And the size of my arrow shows, and we use a bit of a physics term, magnitude. The number, right, the size, the magnitude. What I mean by that is, if you look over here, I drew 100 newtons to the right and 100 newtons to the left, but my arrows are the same size. You can see the direction, they're in opposite directions. If you look at before that, this arrow is smaller. It doesn't always have to be exact. You could draw this arrow at 10 centimeters and some questions will ask you then this arrow would be 3 centimeters. Fair enough. So the size of your arrow shows you the magnitude, the size of your force. The arrowhead shows you the direction. Okay. And another word for that, where your resultant force is 0 newtons, is everything's equilibria. Right? So if you get a question like, what is equilibria in forces? It's when your resultant force is 0. Okie dokie. There is a formula for this, but I don't do it. I just draw it. I think about it. Right? And I'd like you to do that. I'd like you to think about it because that makes physics fun rather than, oh, look, I'm plugging it into a formula. Now, some of you are new. If you're new, you'll get used to this. You know, at year 8 last year, when they were year 7, outperformed year 9 and year 10. And I think you guys are doing amazingly well. So the first 10 questions here, the answers are there. So you may have to go back and look at it because you're not going to remember everything I say. And I'm going to convert the intro. The medium ones get harder. So I've done 11 here. Car has a forward, I draw the car as a circle. Car has a forward force of 500 newtons and a backward drag force of 200 newtons. So I've drawn that as minus 200. What is the resultant force? 500 minus 200, 300 newtons. Okay. But you got to draw it. You got to draw, and this is it. Today's about drawing arrows. All right, sweethearts, I'm going to stop recording.